Hi there, in this video clip I want to talk about a family of hydrocarbons. Hydrocarbons contain just two things, hydrogen and carbon. I previously mentioned a family of hydrocarbons called the alkanes. In this clip I want to talk about another homologous series or family of hydrocarbons called the alkenes. Alkenes have a general formula of CnH2n. N is simply a number, so for example, if N is 2, the formula of the alkene, the hydrocarbon, would be C2 2 times 2 H4. That is an alkene. Let's say when N is equal to 3, it would be C3H8. When N is 4, it would be C4H8. Let's quickly look again, I've mentioned this before, of the structural formula of ethene, C2H4. C2H4. Carbon's got a valency of 4, and it's always got to be joined to 4 bonds. So I've just said this, there was the C2H4, so its structural formula would be valencies 1, 2, that one, 1, 2, 3, 4. It would be CH2 double bond CH2. Double bond. When we've got a double bond, it's said to be unsaturated. Let's look at another example now. Propane, C3H6. 1, 2, 3. We know it contains a double bond, it's an alkene. Let's put the double bond in there. And as I've said, carbon's got a valency of 4. It's got our 4 bonds joined to it. So that's got a carbon 1, 2, 3, 4. That carbon, it's already got 1, 2, 3. Put an H in there, and that one's only got 1, so it's 1, 2, 3. So let's draw it out. That would be the structural formula of propane. Let's look at a final example. Butene. Butene, C4H8. Let's draw out the carbons. 1, 2, 3, 4. I'll put the double bond there, but you can see there I can put the double bond in an alternative position. Let's put it, say, there. And if I add the hydrogens to that again, don't forget to always have 4. 1, 2, 3, 4. That one, 1, 2, 3, 4. That one, 1, 2, 3, 4. That carbon, 1, 2, 3, 4. They are all hydrogens. That is the first structure, and that's the first carbon, and that's sometimes called but-1-ene. And guess what that one's called? That would be but-2-ene. And if I put the hydrogens on that one this time, that's 1, 2, 3, 4. That one, 1, 2, 3, 4. That one, 1, 2, 3, 4. That one, 1, 2, 3, 4. And that would be but-2-ene. Isomers, by the way, they're sometimes called, they have the same molecular formula, but the atoms are arranged in a different sequence. different structures, same chemical properties again, but different structures. Alkenes are more reactive than alkanes. They got that double bond gives them increased reactivity, which means from the chemistry they're more reactive and they can be used to make a larger range of other compounds, molecules, substances, molecules which are useful in, for example, in the manufacture of polymers or plastics. Let's, going back now, look at ethene. Its formula, I've said, is C2H4, and it contains a double bond. It contains that double bond, so that is the structural formula of ethene. Ethene, like all alkenes, undergo addition reactions, i.e. something adds onto it. I'm going to just reposition those hydrogens. It's exactly the same still, but what happens is I can add an addition reaction, something across that double bond here and there. For example, if I took bromine, it would add across that double bond there. Dibromoethane. Let's take another example. If I took water, H2O, water consists of a hydrogen and a OH, H2O, it would add across that double bond, an H there and an OH there, and it forms an alcohol. And there's other examples of this. If I took something like hydrogen itself, it would add across that double bond and form ethane. So alkenes undergo addition reactions because they've got that double bond which makes them reactive. Oh, by the way, hydrocarbons, they burn in oxygen to form water and carbon dioxide. If they completely burn, you don't get a smoke. But if you've got incomplete combustion of a hydrocarbon, it burns with a smoky flame. Let's just look at the one example. When I burn a hydrocarbon, let's take for example again, let's take the case of ethane, C2 ethene, the case of ethene burning with oxygen. We know this, it forms carbon dioxide and water. Let's try to balance it, okay? I've got 2 here and I've got 2 there. So let me put a 2 in front of it. So I've got 2 carbons. There I've got 4 oxygens, 2 times that is 5. So how would I make that balance? The answer would be 3 times that is 6, and that is that. Although I've cocked that up again.